Hi everyone, my name is Fran and I'm a graduate hydraulic modeller at Jacobs. I joined Jacobs in September 2023 after completing my master's degree at the University of Manchester. Since joining Jacobs, I've built a wide range of models using the Flood Modeller software for a variety of purposes, including for benchmarking and flood risk assessments. Today we'll be considering model evaluation. So I have one slide on the importance of checking your model, and then we'll jump into a live demo in which we'll take a proper look at some of the pre and post-flight model checks that you can complete using the Flood Modeller software. As Ollie said, there will be time for questions at the end of the webinar, so put any that you have in the questions box and I'll do my best to answer them. So first off, why are model checks needed? Well, it's important to acknowledge that all models are simplified representations of reality and will never be perfect. However, as modelers, we want to ensure our models are as reliable as they can be, and we do this through our checks. For each model, we should complete both pre-flight and post-flight checks. Pre-flight checks are those that we complete before we set our model off to run to ensure there are no mistakes in our model build, which could then propagate through a project. The Flood Modeller software has built-in tools to make completing our pre-flight checks quick and easy. Post-flight checks are those we complete once our model has successfully ran to see how the model performed. We want to look at our 1D diagnostics files, so our ZZD, EXY, and our 2D log file to check mass balance, check for negative depths in the 2D, and read through any warnings or errors that we may have. Flood Modeller will also produce a bitmap of the runtime graphics window at the end of a simulation, and this provides a nice visual record of the model convergence plot. We'll take a look at an example of one of these plots later on in the live demo. We also look at our results through time series plots, cross-section plots, and animations to make sure the results we're seeing make sense. It's all well and good having no warnings or no negative depths, but we as modelers must decide if the results that we're seeing actually make sense. So we'll now jump into the live demo. So for this webinar, I'll be considering the 2012 River Mersey model, which I already have loaded in here into Flood Modeller. This model starts upstream in Stockport. If I just turn this off, we're in Stockport, where the River Tame and the River Goyt merge to form the River Mersey. This model does actually extend all the way down to the Manchester Ship Canal, but for the sake of this webinar, I've chopped off a significant chunk of the model, as I'll solely be focusing on this small upstream area where the two tributaries merge to form the Mersey. Originally, this model was actually 1D only. However, in a previous webinar that I did back in September, I did add 2D elements to make this a 1D, 2D fluvial model. If you are interested in watching that webinar, it can be found still on the Flood Modeller website. So we have our 1D, 2D linked model, and I want to complete some pre-flight checks. We want to ensure that the 1D component of our linked model is as stable as possible. So I'll be focusing on easy ways to do this within the Flood Modeller software. So what I showed earlier was plotting for a single cross-section by selecting my quick chart edit and adding my conveyance curve. And this one is nice and smooth. I then showed the tabular cross-section properties. I selected a few cross-sections at one time, opened up the tool, navigated to the river section property plots, and did a plot of 4 cross-sections. I showed that this cross-section in particular, GOIT 002285, has conveyance issues, and I zoomed in by drawing a box and zoomed out by drawing a box in the opposite direction. As I said, I'm not going to go into this cross-section and correct that now, but we would do that using our panel markers at panel level. So back to my 1D health check tool. I'm going to deselect all of these as I'm just going to check Mannings. So I'm going to hit none, and that will just deselect everything as opposed to going through and manually deselecting. And then I'm going to do Manning's roughness in range. If I select that and hit run selected checks, this will create a separate file. So we can see here within this report that Flood Modeler has made that I have a cross-section with inconsistent Manning's values 002774. So if I navigate to that cross-section, just turn on my labels, open it up and look at my Manning's values, I can see that at a couple of points the Manning's value has been entered incorrectly. And I can correct this manually. Again, just to reiterate, this is checking for non-conformities. This doesn't say whether the Manning's value that has been selected is appropriate for your model or for your cross-section. It's simply highlighting points where there may be issues. Ahead of running our model, we also want to do a visual check on our 1D, 2D linking. We want to ensure that our active area, which I have shown here in pink, is snapped to our link lines, mine are here in red, and that that's also snapped to our extended cross sections, which I can drag in by selecting my 1D data file and just dragging that into the map viewer. If I zoom in down here, I can see there's issues with my snapping. So my link line is snapped to my extended cross section, but my active area is not snapped. This will cause warning messages during the model run, and we'll actually look at some of these together shortly. So once we've run our model, we can begin our post-flight checks. Flood Modeler produces a bunch of files that we can look at to determine how our model has performed, and we can navigate to these files and either view them in a text editor or load them into the map window or within the Flood Modeler software. If I right-click on my IED file, so my 1D simulation file, and select Load Diagnostics and View 1D log file, this will open my ZZD in a text editor. This is a diagnostics file that gives information about the simulation run, including convergence information, a summary of all the units in the model, any error messages, warnings, and then at the bottom we have a mass balance summary. I can also open my spatial 1D diagnostics file, aka my EXY file, by selecting Diagnostics 1D River down here in the bottom right hand corner. If I just extend this out. This file is particularly useful as it's giving spatial context to the diagnostics information, making it easier to locate problem areas within our model. and we can go to the exact locations by right-clicking and selecting highlight and zoom selection. If I close this, if I right-click on my 2D XML file, load diagnostics, I can also view my 2D log file. Again, this will be in a text editor. This is essentially the same as our 1D log file, but for the 2D component of the model. And importantly, will tell you if there's any negative depths. I can also load in my check grids. So there are 6 check grids that Flood Modeler produces that can be used to check different components of the 2D model. I'll just load all of these in and we'll take a quick look together. So firstly, we have our ZSEN check file, and this gives our grid cell center ground elevation. We also have our ZMod check file, which shows any topographic modifications that we've made to our model. So in this example, these shapes that we're seeing here are buildings that I've included in my 2D domain. We also have our ZX and ZY check files, which show horizontal and vertical edge elevations. We have our init check file, which shows initial water depth at the start of our simulation. And we also have our iWet check file, which gives the cell status. If I just extend that, we can see the colour ramp used to identify the different parts of the model. So here we can see in blue my active area, red is my deactive area, and then I can see orange along my link line here. To see specific values, so let's look at our ZMod. We can use the information tool and we can select points in the model and see what's been added. So we can see here where the buildings have been added on to our DTM. We're also able to load in some spatial diagnostics, again through right-clicking on our XML, heading to load diagnostics and selecting load spatial diagnostics data. I've done this previously, that's why it's asking me to overwrite. You shouldn't have this pop up. This will then load in a shapefile with diagnostics data that helps to identify and troubleshoot issues within the simulation domain. We can turn on our labeling, which I already have turned on here, to better understand what problem we're seeing at which point. And I always add a frame to my labels. I just find it easier to read. This is all done under the properties window, under labels. As we saw earlier, our snapping down here between our active area, our extended cross section, and our link line was not done correctly by me in the previous webinar. And if I zoom into that location, we can see this isolated active cell warning message that Flood Modeler has given us. So we know it's working. Another thing just to note here is the importance of asking yourself, does the location of this warning or this instability actually matter for the purpose of your study? So this will vary from study to study and is solely down to you as the modeler to decide. I'm conscious of time just because of the issues I had earlier, but I'll just quickly run through what these remaining diagnostics do. So we have our load ZMod check file, which will load 2 files into our map viewer, which show where elevation data has been added and the triangulation of the ZMod feature. And then finally, we have our view simulation summary spreadsheet, view 2D mass balance file, and view 1D linked flow summary file. And this will open Excel spreadsheets with additional diagnostics information in. We also have the bitmap that I mentioned earlier. If I just open up an example of that. So we have our bitmap here. This gives us a visual record of the model convergence plot. This file is found in the same location as where your results were saved. And here is what this looks like for this model. So as we can see, our convergence does not go above the tolerance level, which is great. If convergence was an issue in our model, we would see the lines extend above this point and they would be red. So I've spoken about a lot of the diagnostics files that Flood Modeler produces, which can be used to understand how our model performed. Once we've completed our thorough checks, we can then look at our model results through our time series plots, cross-section plots, and animations. I don't have time to do that today. However, I think it's important to say again, when you view your results, you should continually ask yourself, does this make sense? So, for example, let's say you're looking at an animation of your 2D results. Do the flow paths you're seeing make sense? Or if you're looking at a cross-section animation of water level, is the animation smooth or is it jumping all over the place? Can these jumps be justified by, say, a mode shift in a structure, or is there something wrong with the model setup? There are plenty more things that I can say on this, but the focus of this webinar was to check through Flood Modeler, so I'll leave it at that today. In this webinar, we've discussed model evaluation, and we touched on why model checks are important and how to quickly and easily complete model checks within Flood Modeler. Thank you for joining me today.